Find dx dt in the diagram below when y is 3. Well, we have a diagram and there's a ladder in brown leaning against the wall, and we see the top of the ladder is moving down at the rate of -2 meters per second. The ladder's height is y. And we have dx dt, which we are trying to find, which is the rate at which the ladder is moving away from the base of the wall horizontally. So how can we find this? Well, we have x, y, and 5, and we know how to relate these three things using Pythagorean theorem. We know x squared plus y squared is 5 squared, or 25. But that doesn't really give us anything yet. How can we find dx dt using this? Well, what we can do, we can differentiate both sides with respect to time, because that's going to give us dx dt on the left side of this equation, and we can maybe use that to figure out what dx dt is. Let me show you what I mean. By taking derivative with respect to time of x squared, we get 2x times dx dt. For y squared, we get 2y times dy dt. And when we take derivative of 25, we get 0. And we see we have dx dt right here, and that's what we are trying to find. But we don't know what x is, we don't know what y is, we don't know what dy dt is. So we have to figure out what x, y, and dy dt are, and we can plug the values into this x, y, and dy dt, and maybe we can use that to find the dx dt. Well, we know y is 3 at this moment, so we know y has to be 3. How about dy dt? Well, we know dy dt is -2 meters per second, so it's -2. How about dx? How about we're trying to find the dx dt? How about x? Well, we know at this case y is 3, so we know x squared. Let me rewrite that. X squared plus y squared, or 3 squared, is 25. So we can use this to find x. X is going to be x squared plus 9 is 25. Also, x squared is 16, or x is 4. So we know x is 4. So we can now use this to simplify this equation and find the dx dt. That's going to give us 8 times dx dt. 6 -12 is 0, and so 8 times dx dt is 12, or dx dt is 12 over 8, or 3 over 2. So that, or meters per second, that's going to be the unit. So the ladder is moving away from the wall at a horizontal rate of 3.5 meters per second.